So even if you don't understand calculus, I'm going to explain how calculus works to solve this problem. And I'm going to explain the problem in just 1 second. All you need is really kind of some basic algebra skills, but I'm going to explain this problem and the solution to the problem in such a way that hopefully anyone can understand. But let's take a look at this basic calculus word problem. Now, what's going on is there is a person on top of a roof of a building, and the height of this building is 96 feet. Now, actually, what's occurring is that this ball, now it looks like it's arcing over, but technically what's going on, it's being thrown straight up. So I just kind of did it this way to give you a sense that the ball is going to be going up and then back down to the ground. But the ball is going straight up and then straight back down. Now, the initial velocity of the ball, okay, now it looks like this person is throwing it at this height, but basically we're going to simplify this problem, and the ball is going to really kind of start its journey right at this height right here, which is 96 feet, and the initial velocity of the ball is going to be 80 feet per second. So it's going to go up. And then, of course, gravity is going to do its job and stop the ball. And then the ball is going to go all the way back down and hit the ground. So we want to answer a series of questions about this event. Now, there is a mathematical way to describe what's going on with the path of this ball. I'm going to show you that right now. So this is called a position function. So if we know t is time in seconds, we can get the position of this ball anytime we like through this journey. So in other words, right here, let's suppose this, the ball is, or we want to know 5 seconds into the flight where the ball is. Well, we just plug it into this function, and this function will tell us the answer. Now, this function s of t is equal to negative 16t squared plus 80t plus 96 is something that you can derive from physics. And it's actually not too complicated to get this, but that is a separate discussion. Okay, so hopefully you got the gist of what's going on. Again, the initial speed of the ball is going to be 80 feet per second upward. Okay. All right, so here are the questions that we are going to answer in this video or for this problem. Okay, so the first question is, how long is the ball in the air? So that would be, what is the total amount of time for the flight of this ball? Okay, so the second question is, what time does the ball pass the roof? So kind of going back up to our little diagram here, the ball is going up and then it's going to pass the roof at this time. So what time is that? Okay, so the next question here is, what is the average speed for the first 2 seconds of this ball? So the ball is going to go up, and for the first 2 seconds, what's the average speed? Okay, now this is in contrast to our next question, and that is the instantaneous speed. So what's the instantaneous speed of the ball at time equals 2 seconds? So let me go ahead and just show you this real quick. So let's suppose the ball is at this moment right here, or this height at time is equal to 2 seconds. So 2 seconds into the flight, here is the ball. We want to know the speed of the ball at that precise moment. So that's called instantaneous speed. So the next question is when is the instantaneous speed equal to 0? So let's think about that. So the ball is going to go up. It's starting its journey at 80 feet per second, and then it's going to reach some point, right? So gravity is going to stop it, and then it's going to start coming back down. Now, at what time is the ball speed going to be 0, right? The ball is actually slowing down, and then finally it's going to stop. In that precise moment, it's going to start coming down. So when does this happen? So we're going to figure that out. Okay, how many seconds into the flight is the ball speed 0? All right, so the next question is the instantaneous speed when the ball passes the roof? So we're going to determine the time this occurs and also how fast the ball is going at that precise moment when the ball is passing the roof. And then our last question is, what is the instantaneous speed when the ball hits the ground? So after the ball goes up and then it comes all the way back down, right when it hits the ground, how fast is it going? All right, now if you know calculus, this is enough information for you to figure this out. And of course, you can advance through the video to see the various solutions to these components or these various sub-questions, but I am going to break all of this down in such a way that anyone will be able to understand. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help in math, come on over to my site, tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, make sure to like and subscribe, as that definitely helps me out. Okay, so once again, here is our problem. There is the function, and here are all the questions we want to answer. And let's go ahead and start with question A. Okay, so how long is the ball in the air? Once again, this is our question A. And remember, the ball is starting its flight at the top of the roof. And of course, that's 96 feet high. So it's going to take off, and then of course, gravity is going to do its job, and then it's going to go all the way back down to the ground. So what is the total amount of flight time for this ball? Well, the correct answer is 6 seconds. Now, this is what we need to be thinking about, right? S of t is equal to 0. But what does this mean? Well, let's go back to this function here that I gave you in the beginning of the problem. And this function is a formula for where this ball is going to be at any time t. So at t equals 1 or 1 second into the flight, how high is this ball going to be? So to determine that, all we have to do is plug in 1 for this t, do all this math, and this will give us the position of the ball, basically the height of the ball. So we need to be thinking about this position function. So where is the position of this ball when it's finished with its flight? Well, we have to think about this for a second, right? So the ball is starting its journey at 96 feet, and then it's going to go up, and then eventually it's going to be at what height? It's going to be at 0. Okay, that's where the flight ends. So we need to think about when the position of this ball is at 0. Okay, i.e. the height of the ball is 0. So we're going to set this position function, or this entire thing, equal to 0 and solve for t. This will tell us the time when the ball is 0. Okay, so let's go ahead and do that simple algebra. So you want to keep this position function in mind throughout the problem. All right, so s of t is equal to negative 16t squared plus 80t plus 96. So we're going to set this equal to 0, and that's going to tell us when the ball has 0 height, i.e. when the ball stopped flying. So here is our position function. We're setting it equal to 0. Now, if we notice here, we have a negative 16 in front of this t squared, an 80, and a 96. We'll hopefully recognize that 16 is a factor of all these numbers right here. So we can simply divide everything by negative 16. So in algebra, we want to make our life really easy. So if we divide each one of these terms by negative 16 to include this 0 over here, we're going to get this. So that is t squared minus 5t minus 6 is equal to 0. All right, so once again, we're talking like first year algebra here. So as long as you understand algebra, you will be able to understand the calculus and physics, by the way, for this problem. All right, so we have a quadratic trinomial here, and we want to solve this, and the best way to solve this equation here for t is to factor this. So t squared minus 5t minus 6 is equal to 0. We can factor as t minus 6 times t plus 1 is equal to 0. And then, of course, we can set each one of these factors equal to 0 and solve. So in other words, we're going to take t minus 6, set it equal to 0, so t is equal to 6, and t plus 1 is equal to 0. So t is equal to -1. So our answers are is the following, right? So t is equal to 6 and t is equal to -1. But remember, t is time in seconds, so we don't really have negative seconds, so 6 is the correct answer. All right, so the total flight of this ball before, well, when it hits the ground is 6 seconds. Okay, so hopefully this makes sense to you, and keep this first little problem in mind, or how we use the function here to solve, these problems, because I think you can figure a lot of these problems out. Some of this stuff, of course, is going to require calculus, but let's take a look at our next question here, and that is B. Okay, so what time does the ball pass the roof? Well, the correct answer here is 5 seconds. Now, what are we thinking about? Well, here is the ball. The ball is starting its journey at 96 feet. Okay, so what time does the ball pass the roof, or what time is the ball at the roof? Well, if we think about it, time equals 0. The ball right there is at 96 feet, right? That, of course, is the height of the roof. But there's going to be another time, right, where the ball is kind of on its way down, that it's passing the roof. So what we need to do is set that position function equal to 96 feet, and then again solve for t, which is the time in seconds. All right, so let's do that now. So again, we're talking about simple algebra here. So here is our position function again, and we're going to set it equal to 96 feet. So in other words, where or when is this going to happen? When is the ball going to be at 96 feet? And t is the time in seconds that this is going to occur. So again, we're going to divide everything. Matter of fact, well, the first thing we're going to do is move this 96 over to the other side of the equation, and then we can divide both -16t squared and 80 by 16. So that simplifies down to this. And hopefully you have enough algebra skills to see what I'm doing. But all of this is going to distill down to t squared minus 5t is equal to 0. All right, so here we can simply factor out a t. So t times t minus 5 is equal to 0. And of course, I can distribute this t back in to get to t squared minus 5t. All right, so now, again, we have a quadratic equation. So we set each factor equal to 0. So t is equal to 0, and we already knew that, right? So at time equals 0, the ball is already at 96 feet because it's kind of sitting up there waiting to start its journey. But this factor right here, t minus 5, we set that equal to 0, and solve, we get t is equal to 5. So at 5 seconds into the journey, the ball will be passing the roof, or at the height of 96 feet. So continuing on with question C, we have, what is the average speed of the ball in the first 2 seconds? Now the correct answer is 48 feet per second, and we have a formula here that we need to use to calculate the answer. But this is basic algebra, it's not that complicated. All right, so once again, we have the ball, it's taken off at 80 feet per second. That is the initial speed at time 0. So the ball is going straight up. And then, of course, gravity is slowing it down, right? So the ball is faster here than it is up here. Eventually, it's going to stop and then reaccelerate back to the ground. So the first 2 seconds of this flight, what is the average speed? Now, this is much different than the instantaneous speed. So, for example, let's say 5 seconds into the flight, the ball is right here. So in that precise moment in time, what's the instantaneous speed? So we're going to calculate questions like that in just a second. But first, we want to determine just the average speed of the ball in the first 2 seconds. So to determine that, what we want to do is determine the change in s. And that's just the change in position in feet. Okay, so we can determine that with our function. So we're going to determine the change in position of the ball. In other words, how many feet did it travel in the first 2 seconds? And then we're going to divide that by the change in time, which of course is going to be 2 seconds minus 0 or 0 minus 2, which is 2 seconds. So we just need to determine how many feet the ball traveled, and we'll divide that by 2 seconds. So again, the average speed when it comes to problems in physics and calculus is the change in position over the change in time. All right, so once again, I need to stress that this is the average speed, not the instantaneous speed. All right, so let's just go ahead and do the number crunching. And remember, we have our position function here. So remember, at any time t, we'll know the position of the ball, i.e. the height of the ball. So here we're going to plug in a 2 because we don't want any negative numbers, and here is 0. So this value right here in the numerator will give me the total amount of feet the ball traveled in those 2 seconds, and then we're going to put that over the difference in time, which of course is 2 minus 0, or 2 seconds. All right, so let's just do this lovely number crunching, and I'm going to basically spare you the algebra here, but S of 2 is 192. So to get that value, all you would have to do is plug in a 2 for t here, do all this number crunching, and you would get 192. So if we plug in a 0, you're going to get 96, and that's pretty easy right here, right? So when t is 0, these things zero out, and we're left with a 96. So, and that makes sense, right? What is the position of the ball at time is equal to 0? Well, it's 96 feet, which is the height of the roof. Okay, so 192 minus 96 over 2 minus 0, which is the difference in time, is going to be what? Well, 192 minus 96 divided by 2 is 48, or 48 feet per second. Okay, so up to this point, we have not needed calculus to answer a question, but now we do. So question D is, what is the instantaneous speed of the ball at time is equal to 2 seconds? So maybe the ball is right here at 2 seconds, time is equal to 2 seconds. So we're not interested in the height of the ball, the position of the ball, we want the speed. So how can we get the speed of the ball in this precise moment? Well, we're going to need to understand some calculus and basic physics, but the correct answer here is 16 feet per second for those of you that want to check your work. All right, so we need to find the first derivative of this function, all right, this position function. So the notation for that is s prime of t. So this is where this mysterious calculus stuff is going to help us out. And then we need to evaluate the first derivative for 2 seconds. So let me explain this because this is really not that complicated. All right, so just kind of ignore the math here and just kind of focus in on the big picture. All right, so the big picture is this. Here we have a function, a physics function that describes the position of the ball at any time t, right? So the ball is going straight up and then straight back down. So at any time in seconds, we'll know the height of the ball in feet. All right, so again, this is the position function, but this right here is only basically relating time and feet position. So how can we get speed or velocity, instantaneous velocity when this ball is traveling? Well, that's where we need the first derivative. Okay, so here we have a position function, right? So again, we'll know the position of the ball at any time t. Now we're going to find something called the first derivative of this position function. Now the notation for that is s prime of t. Now this is a new function, all right? So this function here tells us the velocity, the instantaneous velocity of the ball at any time t. So we're going to go from position to velocity, all right? So we're taking the position function, we're going to find the first derivative, and now we have a new formula that will tell us the instantaneous velocity of the ball at any time t, i.e. at any seconds through the journey, we can determine the instantaneous snapshot speed of the ball at that moment in time. Now, if we take the derivative of the first derivative and we end up with something called the second derivative. That's s double prime t. Now, a lot of you might be saying, Mr. YouTube Math Man, this is getting complicated. Well, it's not that difficult, all right? So the math here was what I'm saying, but I just want you to pay attention to the big picture concepts. So here is our first derivative. If we take the derivative of the first derivative, we end up with the second derivative. Now, that will tell us the acceleration of the ball, right? So the ball is going up, and let's think about it. Its acceleration is slowing down because eventually it's going to stop and then it's going to reaccelerate. So if we wanted to know the acceleration of the ball anywhere along this journey, we would need the second derivative. In other words, we would just have to find the derivative of the first derivative. Okay, so if you understand all of this, well, you are understanding a lot of physics and calculus. So somebody might be saying, okay, Mr. YouTube Math Man, how do you find the first derivative? All right, so this is not that difficult. So here is our position function. So to find the first derivative of this function, we're going to use a simple rule. Effectively, to find derivatives in calculus is you basically follow a lot of simple algebraic rules. Okay, for the most part, of course, there's more challenging problems, but this is a very easy problem to find the first derivative. Okay, so this is the answer. S prime of t is equal to negative 32t plus 80. So this is the first derivative of our position function. And let's talk about how we got the answer. So what we're going to do is we're going to make sure our function here is written highest to lowest power. So we're going to take a look at this t, and we're going to focus in on the exponent. So we're going to take this 2 and multiply by that negative 16. So 2 times negative 16 is negative 32. So the rule is, once we take this value, this exponent, and multiply by the coefficient, the number in front of the variable, we're going to write it right there, and then we're going to drop down the exponent by 1, exactly 1. So 2 minus 1 is 1. So now we have negative 32t to the first, but we don't need to write that. So that's just negative 32t. We don't need to write the first power. So negative 32t is the same thing as negative 32t to the first power. Okay, so that is that. And then over here we have t to the first, and we're going to multiply that 1 by 80. That's 80. And then we're going to subtract 1. So 1 minus 1 is 0. Anything to the 0 power is 1. So this is effectively 1 times 80, which is 80. All right, so this is the first derivative of our position function, which is a new formula for us to determine the instantaneous velocity of the ball at any time t. So the question, again, is the instantaneous speed of the ball when the ball is 2 seconds into flight, or at 2 seconds, that precise moment in time, how fast is this ball going? All right, so all we have to do is literally plug in 2 for this t, right? Because this is in seconds. So here we'll replace t with 2. So we have negative 32 times t, that's negative 64 plus 80. Negative 64 plus 80 is 16, or 16 feet per second. This is the instantaneous velocity of the ball at 2 seconds. So I hope you're learning something from this video. And if that's the case, make sure to subscribe and hit that bell notification. This really does help me out on YouTube. Now, if you need additional help in math, make sure to check out my full main math courses. You can find links to those in the description of this video. So let's go ahead and get back to the problem. So now that we understand that the first derivative of the position function is the velocity function for instantaneous speed, we can easily answer question E. And that is, when is the instantaneous speed of the ball 0? Well, the correct answer is 2.5 seconds. But what does this mean? Well, remember, the ball takes off here at the top of this roof at 96 feet at an initial speed of 80 feet per second. So it's already moving, and then gravity is slowing down the ball, right? So at this precise moment, the ball is basically stopped when it's kind of maxed out, and then it's going to reaccelerate back to the ground. So what time does this occur? Well, we want to know when the velocity is 0, right? Because as the ball is going up, it's slowing down. Eventually, it's going to stop and kind of suspend in mid-air. So what we need to do is take that derivative, that velocity function, the first derivative of the position function, and set that equal to 0, because that will tell us at what time t, if we can solve this equation, that the speed of this ball is 0. The instantaneous speed of the ball is 0. All right, so let's go ahead and do that right now. And again, we're talking about basic algebra. So this, again, is the first derivative, right? So the first derivative of the position function gives us instantaneous velocity at any time t. So that's negative 32t plus 80, and we're going to set this equal to 0 and do this simple algebra, which is not that difficult. So negative 32t plus 80 is equal to 0. We'll move the 80 to the other side by subtracting 80 from both sides of the equation. And we have negative 32t is equal to negative 80. So to solve for t, all we have to do is divide both sides of the equation by negative 32. And when we do that, we get 2.5 or 2.5 seconds. So if you understand here how the first derivative of the position function gives us instantaneous velocity at any time t, well, these last two questions are going to be easy to answer. So let's take a look at question F. What is the instantaneous speed of the ball when it passes the roof? Well, the correct answer is negative 80 feet per second. So why is this negative? Well, remember the ball is going up and then it's going back down. So as it's going up, speed is going to be positive because that indicates a positive direction. Negative means that it's going towards the ground. So if you have a negative speed, that means the direction of the ball is downward, and positive speed means the ball is going upward. All right, now recall earlier in the video, we determined that the ball is passing the roof at 5 seconds, right? So there's actually two times where the ball is at 96 feet, which is basically what the question is asking. That is time is equal to 0, right? So that's where the ball starts, but there's another time, and that is 5 seconds. So we already determined that, but what we want is the instantaneous speed at when? Well, when is, or how fast is this ball? What's the instantaneous speed of this ball at time is equal to 5 seconds? So effectively, all we have to do is plug in 5 seconds into our velocity function here, instantaneous velocity function, the first derivative of the position function, and we'll get the answer. So again, very basic algebra. So here is the first derivative of the position function. Again, I'm stressing that this gives us velocity, and if we wanted to take the derivative of this, we would get the acceleration. All right, so here all we have to do is plug in 5 for seconds. T again is time in seconds. So what is S prime of 5? So we're going to replace this T with a 5. So negative 32 times 5 is negative 160 plus 80, and we get a negative 80. And again, that negative sign means something. It means that the direction of the ball is downward. So the ball is going downward negative 80 feet per second at time is equal to 5 seconds. All right, so our last question is going to be very easy, and that is what is the instantaneous speed of the ball when it hits the ground? So some of you might be thinking, well, the ball stopped. The speed should be 0. Well, at that precise moment, the ball is actually, traveling. So right at that instantaneous moment it hits the ground is the speed that we're interested in. So recall, we determined that the total flight time of this ball is 6 seconds, right? So 6 seconds is when the ball comes to rest. So all we have to do is determine the velocity at 6 seconds, the instantaneous velocity. And the correct answer is negative 112 feet per second. So once again, we're going to use the first derivative of the position function to tell us instantaneous velocity. So we'll find S prime of 6. So here is the number crunching. We're going to replace t for 6 or 6 seconds. So negative 32 times 6 is negative 192 plus 80. That gives us negative 112 feet per second. Okay, so hopefully this video give you a sense that calculus and physics is something that you can do, right? So even if you only know basic algebra, you can definitely understand this stuff. Now, of course, I'm simplifying a lot of things here, but really, if you are pretty strong in algebra, that's a good indication that you can do very, very well in calculus and physics. But of course, there is a lot to know. Now, if you really want to be ready for calculus, a full calculus course, or a full physics course, what you need to do is be very strong in the concepts of pre-calculus. So I'm going to leave a link to that course in the description of this video. But hopefully you enjoyed this, basic calculus word problem. And if you understood everything here, well, that's a good, you'll walk away from this video actually knowing quite a bit of calculus and physics. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.